Hello, good morning, everybody. Welcome to this session of building serverless apps using Azure Cosmos DB and Azure Functions. So let's go quickly over the agenda. I will be briefly talking about what is Azure Functions, how you can develop it, and then we will look at the Cosmos DB change feed, and we can see how we can mix two together and build real applications. And the last one, we will write some code to solve a real business problem. And in the end, we have customer stories. We have two customers here with us, and they will be talking about how they are harnessing the power of Cosmos DB and Azure Functions and solving the real business problem. So it's not going to be all theory, and we are just talking about some code, but we will see how these functions are put together to solve real business problems. And in the end, we will leave some time for question and answer. We have Chris Anderson here with us from Azure Function, and hopefully we can answer most of your questions here. So as most of you must have already seen the slide, that we gain in productivity as we keep going more and more inside the cloud. As we move from infrastructure as a service to platform as a service and a function as a service, we gain in productivity, and we stop worrying about other stuff, like where is my hardware, where's my software, and patches and upgrade and things like that. So the more you go inside the cloud, you gain in productivity. So benefit of serverless. Here we manage apps, not servers. In fact, not even apps. We manage just the function. So you just write the function, and you don't worry where it's deployed and how it will be instantiated, at least initially. So there are other options where you do take the full control. But you can start with just write a function and deploy it. And it's as simple as that. Now, once you abstracted away yourself from software and hardware and patches and upgrades, you get into big savings of DevOps cost. And because of these two benefits, you get faster time to market. I think you guys must have heard this phrase many times in this build, that this is a wonderful time to be in technology and being a developer. And it's really, it's amazing, especially old people like me who were in this industry for COBOL time. I don't know how many people even worked on that thing. But today, from your conception, like you thought about something, and you can have it deployed and working in production, that time has shrunk. That time has shrunk because of this technology of cloud and functions. Like you can think about something, and you can have a prototype done in few hours. And one of the apps I will be showing you, maybe I'll talk more about it when I will show you that app in 1992, when I built it, took months. And today, we can do it in few days. So it's really faster time to market in true sense. And because of the ease of this Azure Functions, the good patterns of microservices and all are possible. We all know the benefit of these microservices, that you can have these small services. They are independent. You can deploy them independently. You can debug and develop them and scale out independently. So all this is possible because of Azure Functions. So functions, what is functions? So the definition of function is it's a self-sustained code which solves a business problem. So that is, loosely I will define, that's an Azure function. Now, as we all know, that function can have other functions and all that. But when I say Azure function, by that I mean you have a service which is solving one of your business problems. You can develop them locally and then deploy them on the cloud. You can debug also locally. You can just write few lines of code, and we'll see that as we'll go along, that how easy and simple it is. And functions boost the productivity through trigger and binding. We will talk more about them. And you can choose a variety of programming languages, C#, F#, JavaScript, TypeScript, or Java. You can choose any of the languages to write functions. And it can really integrate with the existing DevOps processes. In this slide, I'm showing what is available today. One thing you will notice, there's 1x and 2x. There are two versions of functions. 1x is already in public. It's GA. And 2a is public preview, and it will be released soon. The difference between 1 and 2 is addressing the .NET Core market. And you can see all this trigger. By trigger, we mean anything happening in these services, like blob storage, get some file there, and you can trigger a function because of those. External services can trigger a function because of some activity happening there. And then we have input and output binding. That's basically a declarative way of defining input and output on the function. So we will see another example how easy it makes to write code connecting to all these different services. Yesterday, when I was writing the slide, the previous one, looking at the trigger, and suddenly something came in my mind that, this session, this video is recorded, and it will be put on channel 9 after like 24 to 48 hours. And the reason is, once the talk is finished, they'll take this video and put it in a queue where we have all these hundreds of videos going in front of them to be processed, and then they can be put on the website. And a few years back, I was thinking, we have this hundreds of thousands of computers in Microsoft. On every dev's desk, we have 1 or 2 or 3 computers, and they all are sleeping in night, doing nothing. And I'm sure in your enterprise also, you have all these computers which are just sleeping and doing nothing. And I was thinking how I can use this computer in night to do some useful task. Machine need not be sleeping. And a few years back, it was really difficult to do things like that because you have to have this whole orchestration engine and how you will divide the task and who will pick it up and fault tolerance and all those things. Now, because of these paradigm of Azure Functions, serverless code, and queue and cloud, all these machines you have, they can be having some Azure function running in there, listening to some queue for the what, and they will work. So I thought, this is something interesting. I should just bring it up, and I'm sure you guys will come up with a lot of different use cases where you can really reduce your cost, and you can have all these machines which are sleeping at night can start doing some work. So let's build some functions and see how easy we can write them. They say in every demo something will go wrong, and today my mouse went off. So I have just the DOS window open. I already installed my Azure Functions runtime. So to write the function, I will say func new. And as you can see, we have option of many languages here: C#, Bash, F#, TypeScript. So here, I just choose C#, and then I can see all these options are there for me to write Azure function, and there's a template. It's all ready to go. So we'll just choose this HTTP trigger, or maybe HTTP trigger with parameters, and I give the name, Azure Function 7, and that's it. Now, let's go and make sure my host is running. Now let's go and test it. Okay, from my, oh, sorry. Isn't it 7?
I think you need to change the name in the function.json for the wrapper.
AF7. So when I look at here, so this is the API, AF5, okay, AF5. So this is the function I wrote. Let me just quickly open it in code. So this function is created by just writing that function new. And you can see the code is here, and you can start writing yourself whatever code you want to write. Now, as I said, there's a multiple ways to create the function. Now, let's quickly look at how I will create. Now, suppose you don't have any tool. You don't have Visual Studio Code. So you can just go on the portal and write a function there. And why I want to come here to the portal. Sorry, I already opened this tab beforehand, before the presentation, but somehow it got closed. Now, to create a function in the portal, you click on this create a resource. And that's why I tried to open it before, because it takes some time, and everybody waiting on this, not a good idea. So here we can start writing function, but before that we have to create a So all these functions, they are hosted inside an app. So function app. Sorry, I should have typed functions. Okay, function app. Why I'm trying to show you this, because there are a couple of points we should bring it up. Function app, when we say create, as you can see, this screen just asking you very few things. You just put your function name, app name, and then the subscription and the resource group, which you already have. And then you have an option to have OS. You can choose Linux or Windows or Docker. So here's another thing you have to think about: consumption plan and app service plan. So the difference between two is consumption plan. If your function is in consumption plan, it will be just charged for whatever resources it's consuming. And if you want to have more control on your function app, then you can host it into the app service plan. There are other couple subtle differences are there. So these function apps, they will sleep after 5 minutes if there's no activity, but it will sleep maybe after 5 minutes. You can increase it for 10 minutes with the configuration. And if there's a trigger happen, you have to wake up if your function is running into the app service plan. It can be triggered by HTTP, but all other triggers, you have to make sure it's already up. But in consumption plan, the system will wake up your function. So that is one of the big difference. And of course, there are other things. If you want to really want to use your own hardware, software, and how much RAM it should have, what is the CPU, and things like that, then you can choose app service plan. And if you will choose this, you can go ahead, and then you can see there's a lot of other options are there for you. Sorry. So when you say create new, then you have all these pricing options, and each option will give you the how powerful machine you want and how you want to deploy these functions. So that's about defining your function application, which I need not do that because I already have. And that's it. Once you say create, it will create your function app. And if I go back, so this is the function app here. As you can see, there are functions already inside an app, and I can go and say create a new function. And you can see there, these are the options you have. It's out of the box. These options are given to you. Interesting one I saw yesterday was you have SAS token generation, and then there's a webhook for the Git also. A few days back, I was talking to some customer, and they were wondering, a lot of our keys, master keys, and things like that, we put in the GitHub. And if you have a big enterprise, it's very difficult to police all this because devs are writing some test application, and they had a key, and they just check in by mistake. Now with these Azure functions and all, you can write the hook with the GitHub, and then you can make sure, while checking, you can go through the code and see if there's any key is there or not. So I can just choose here one of the functions. Let's choose this HTTP trigger. And here you can see today the option is C# and JavaScript, but these options are increasing every day. We are adding more and more languages. Authorization level is function. By that we mean you have to pass a key to call that function. But otherwise, you have two other options, anonymous and admin. Admin is, again, you have a host key to call the functions. So this is it. Once I say create, my function is created on the portal. So it is as simple as this. And you can go ahead and you can test also. So I choose get, name, $200, OK, and here you see the output. So you saw the simplicity of creating this function and just testing it then and there. And we will go in the presentation, we will use Visual Studio also and write some function which is bigger than just 2 lines. But it just shows the point that how easy it is to write these functions. So we talked about Azure Functions. Now we're going to talk about Azure Cosmos DB change feed. It is a persistent log of records in the order in which they were modified. So if you have a Cosmos DB, a collection, so whatever changes are happening, you can see it on the change feed. Today, it is today it has only insert and updates. Delete is coming soon. Sorry. And you can work around with the delete is just putting the soft delete. And change feed is on by default. You don't have to do anything. You don't have to set any switches. Wherever you have a Cosmos DB collection, you can read it. And you can read this change feed from, if it's a geo distributed, you can read this change feed from any other geolocation. And this is important when you have application which is working across the world. You would like to have better performance, and then you would like to go to a certain geo to read the change feed. You can have multiple applications can read the same collection. So what are the scenarios enabled by Cosmos DB change feed? So one is that we already talked about the Azure function, that you can have some function listening to all these records or all the changes happening in Cosmos DB, and you can do certain things on it. And you can send a notification to Notification Hub. Basically, I feel once you get the change feed in the Azure function, sky is the limit. It's all your imagination, what all you can do. And number 2 is you can do some real-time analytics using Spark, Hadoop, and all that. Today in Cosmos DB, we don't have aggregation, so group by and all, because it is a distributed database. And doing a group by across 1,000 partitions, billions of rows can be very, very expensive. So you can connect Spark, and as the data is coming in stream, you can do the processing on that. I don't know if there's a session on that, but there are YouTube videos on Cosmos DB and Spark. You can see how we can enable that scenario. And then you can move some data to cold storage, move the data to storage blob or other Cosmos DB functions. We already talked about microservices. This is another way that we can enable microservices. So when I'm listening on change feed, suppose I'm a website and selling stuff, as soon as I get an order, I can kickstart my shipping service, tax calculation and payment. All these things can be enabled by change feed, and I think we are going to hear from our customer how we are using it in the real time, in the real business scenario. Next is this, creating a materialized view. So all the data is coming in, and as you already must have heard or seen, Cosmos DB is all about throughput, very, very high throughput and low latency. We can easily go to 2 million, 3 million, 5 million requests per second. And in that kind of throughput, you still want to build some materialized view. You can use Spark and then create the view, put it back into the Cosmos DB in another collection, and have your application look at both the data coming in and the aggregated data also. So that's another way. Third is, we talked about that replicating the data, moving the data to cold storage for long-time keeping. Now, let's see how we can read change feed. There are 3 different ways to read change feed, and each of them have their benefit, pros, and cons. And I will quickly go through all these 3 options and show you some code. So the first option was to have using the document client library. Using that, you can read a change feed. And here in the code, there's a lot of boilerplate code is there, but what we have to really pay attention to is in this line, you just go and find out what are the partitions are there into the collection. So this way you will get the list of all the partition, put them in a partition key range. It's just a list, so you just want to have, because you are using the client library because you want to have a lot of control that you want to read exactly this partition of the data. And that's why we come down to this level, which is, I will say, a very deep level. And then slowly we'll keep going above. And then you'll see how easy and simple it starts becoming. And then here, you set some change feed options. So as you've seen before, you got the partition key range ID, you set that. And then you have other options that you can say, no, I want to read all the change feed from the beginning. So you can get all the data, whatever has changed from the beginning. And then, or you can have the continuation token. And then you say, I just want to read from here. Because when you're reading, in response, you get this continuation token, and you can save it. And then you can use it later to read the change feed from certain place in the feed. And max item count, you are saying how many items you want to read at a time. And then you can put the start time, and you can go back. So you have all the power on the change feed to go back and to and fro to get this data coming to you. And that's it. And after that, once you call this method on the query, execute next async, you will start getting the data into this read response, which I am just displaying here. Don't worry about all this code. All this code will be available to you in the GitHub, and I will share the link with you all later. I didn't talk about client. Client is plain vanilla, document client, which we are creating from SDK here. So let's run it. Meanwhile, close this, guys. It's waiting and listening for changes, this app which we have just written. And I'm going to put some data into the collection. Thank you. Let me restart this thing. OK, finally. So we can see the data is coming in. And this is as simple as this to write how to listen to change feed. Now I want to go and quickly look at the second way where how to read this change feed. The second way is to use the SDK processor library. That's library we wrote. So you can, we abstracted away all this detail from you, that how many partitions are there, what is the change feed token, things like that. And if you will use that library, you will use this observer pattern, where you will just write your one object which will implement this iChange feed observer. And then in this interface, you will just implement process change async. And that's about it. And all the change feed will start coming in here. But it does not mean that if you use this processor library, you use all the control. You do have option to use the token and things like that, and which partition you want to read. But we simplified this very much. So you will just implement that interface, and just this one method you have to define to start reading the change feed. So this is the simplest way. Now I want to write a new function using Visual Studio, and you will see again how easy it is. But before that, I want to talk about the scenario which we are discussing in the solution. So this is the scenario. I have all the cars running, and they have an IoT device, and they are updating themselves continuously. And the feed is directly coming into the Cosmos DB. And today, this scenario is already implemented by Toyota. They have 250,000 or maybe more cars running with data continuously sent to Cosmos DB. And then we are listening on the change feed using the Azure function. And if there's an accident happen, we will know within a minute to have the information come to us, and Azure function is watching for the accident, and then it can activate all different services. You can send the notification to the web page, which is somebody is watching in a control room looking at the map of the city and see where exactly the car is, and you can activate other services like hospitals and fire and or the ambulance. So this is the project I'm talking about. In 1992, I was working in Kuwait for Kuwait police. And we built the same thing for them. 92, I don't know how many of you remember, we didn't have any very smart phones. We had big black Nokia phone. There's no even GPS. So what we did, we put the GPS on police cars. We basically drilled the hole and put the GPS and bought the wire and connected it to the Nokia phone. And we modified their operating system. So Nokia did this for us. And from there, using their latitude and longitude, through the SMS, we send the message to our control room, where we extracted the message, and then used the Sun microsystem, Sun system on their graph, on the map. We showed where the police car is at the moment. That was a multi-million-dollar project. And so many companies involved, and Nokia has to modify their phone and all that. And this whole thing, today, I did, in a couple of days, everything working, and we will see how you can even, have a full solution working in very short time. So let's go and look at the code for this. Let me close these guys before I leave. So it is just reading the change feed which we inserted before. And I'm showing here the partition ID and the token, which you can use to move up and down and read wherever you want. So here's the desktop application where I'm looking at the map and waiting to see if there's any alert happens. Now, let's go and quickly write this function. So if you are using Visual Studio, a lot of things are done for you. Here, you just go ahead and choose Azure function. And I'll just leave it as default, function apps 4. Leave this everything as default. We'll come back to it. Right-click and say Add New Items. And choose Azure Functions. And here, again, we have all those options. We are going to choose Cosmos DB Trigger. So as you can see, this is boilerplate code ready to connect to your Cosmos DB change feed. You just fill up these information, and you can have the whole solution working. So what we are going to do this here is I have this code, which I'm going to copy and bring it here, so you don't have to wait, see me typing everything. So what I'm doing here is, in read-only list documents, we are getting all the documents which are coming inside the change feed. And on these documents, I'm looking if there's an accident happen or not here. And with this, if there's an accident happen, I just put a message on the queue. And on the other end, there are different, again, the microservice architecture. There's a different functions listening on that queue, or the web page is also listening on that queue, and they will show exactly where the accident happens. Here, these 4 or 5 lines are doing nothing but instantiating the queue. I just showed you these few lines of code here because I just wanted to show you what all I'm doing in this function. But we will see later on that you can even delete all these 4 lines and then have the input and output binding concept and just bind the queue on this function and then just return the message, and that's it. So even if I have this few line of code, it's hardly like 10 to 15 line of code listening to the change feed and alerting. Now, before I can run this, I have to set up this connection strings. So here I'm just giving my storage connection string and DB connection, like which collection in the Cosmos DB I'm listening to. And they are defined here. Connection string, DB connection, collection name is this, and database is this. And that's about it. So if I run this function now you see this function is running on my laptop. And the queue is in cloud. So this all integration is very seamless between cloud and our machines. And we can debug it here. And let me do this. This is an emulator which is going to pump some data to show that there's an accident happen. And when I press this thing and look at my map, and you see it takes 5 seconds is default of Azure function, but you can go down. That's why you have this option to use the processor library. You can go down to a second. But below second, you will start churning a lot of CPU. So you see this accident happen here, And what we have done, we have written just few lines of code to connect to Cosmos DB and Azure Function, and putting this message on the queue and activating my whole microservices paradigm. So that was a quick rundown that how you can use Azure Function and Cosmos DB change feed. Now let's listen from some of our customers that how they are using this power and solving the real business problem. So I will invite our Johnson Control, and they are doing a lot of things in IoT. You have the mic?
I have a mic.
OK.
Let
me go back to the PPT. Next. Yep.
Great. Well, thank you. So I'm from Johnson Controls. We've been in the IoT space for a really, really, really long time. We got our start way back in 1883 when Warren Johnson invented the electric telethermoscope. That is totally not made up. That's an actual thing, which is otherwise known as a thermostat. He was a college professor, and his students were complaining about the temperatures in the room and so forth, and so he invented this device that would allow him to be able to see what the temperature is and be able to regulate the control in the room. And since then, we're still doing the same thing, right? We're trying to gather all the kinds of data from all kinds of buildings and other systems and try to aggregate that together so that we can provide insights into people's buildings or their cities or whatever else. But the problem that we've found over a long time is that we end up with a lot of puddles of data. They use this construct of the data lake where all the data goes into, and really what happens is they don't turn into a lake. They're a bunch of puddles on the sidewalk that you can't really get access to because they're all over the place, right? And we recognize this because we constantly were trying to write different types of systems that would integrate together so that we'd be able to join that data to be able to get insights into what's going on. Say you have a piece of equipment that fails, why can't we see the warranty information with that equipment, right? Why shouldn't I be able to see when that was last serviced? And so that's what we set out as a company to try to solve this business problem for your building information system. So when we talk about buildings, there's really two chunks of data, the OT data and the IT data. The IT data is the things that describe the building, such as what floors there are and what sensors are where, but then there's also the OT data that says we have all this HVAC information that says, this room is this temperature, that room is this temperature, and whatever's happening in those spaces. And so what we wanted to be able to do is basically get an insight of gathering all that OT data and IT data together all in one place. And so we started off a couple years ago looking at Cosmos as just basically a document store. We wanted to have a way to be able to deploy something in the cloud, or we wanted to deploy it on-premise. And what Cosmos gave us the opportunity for was that we were able to use Postgres on our on-prem, and because it was using kind of a document store, we were able to port that right over for a cloud scale solution. So we were able to get a lot of really quick insights to be able to see, get that data all into one place. The next thing that we started doing is realizing that documents is somewhat limiting, so we wanted to be able to go deeper, to be able to join that data together as we were talking about the OT and IT data. And so what we started looking at was the Gremlin interfaces in Cosmos to be able to kind of join those data sets together. And what was really cool was they have the capability that we didn't have to necessarily export the data and then re-import it back in. We could actually pivot from using Cosmos as a document store and then use it also as a graph store and using Gremlin as the interface to query that. And so what that let us do is basically describe, on the left there, you see all the different entities. So let's say you have a building has floors, floors have space has equipment, and we're able to see that logical relationship of those things. But besides the relationship, I want to actually see what that sensor is doing. And so what we were able to do is using the Cosmos as a backend, we were able to see that and aggregate that data so that you could click in and look at the actual telemetry data, not just the relational data, but the actual telemetry data itself. And this is really powerful because it's able to give customers insight into the actual, to visibly be able to see kind of how things go. If you ask 3 people to come in and describe a building, you're going to get 3 different explanations of how that building is formed. And so what we've done is we've tried to create, using Brick, which is an open format for describing entities and so forth, we're trying to use that as kind of a standard way to describe that, so you're able to infer those relationships in a much easier way, and that you're going to find one concise way of describing that so you get the same answer from those 3 people. So when we talk about, to the tone of this message of this presentation is how do we use the data, how do we get to the data and aggregate it and so forth. So when you start talking about telemetry data, it's very fast changing, and if you were wanted to graph that, to graph all of the individual raw points is going to be really difficult, and it's going to be really slow. And so typically what we always do is we want to aggregate that data. We want to see what, for a given temperature in a room, we want to see what the daily value is. We want to see what the monthly value is, the yearly or the 10-year. And so what we did is on the top is the original approach that we started down is where you had the data coming in as a sensor. We sent that to the IoT hub, which would then forward to an event hub. And from that event hub, we would insert directly into the Cosmos repository what that raw value is, but we would also want to try to get that aggregate. So we would shove that off to another event hub, and I always like to think of this as a big Plinko board. Price is Right fans out there? Plinko board where you drop the piece in the top and it falls down into the right bucket, and so you do all the aggregations to figure out where exactly that value is. But what you end up with is a big feedback loop, because the more data that comes in, you need to go back out and get those other values, pull it in, and then do the aggregation and then push it back in. And so with some of the things that we've talked about in this session is, there's an alternate way of doing that basically, that sensor pushes into the IoT hub, which pushes directly into Cosmos, which maybe you have a change feed that's hooked up that would trigger a function to say, hey, go aggregate this, and then we can shove it right back into Cosmos. And so you can see by the shape of the data that it definitely gives a different behavior in how many times you have to touch the data before it actually ends up in the repository that you can query. So what's next? We're continually trying to test the boundaries and seeing where we're going to be going. Functions is a really great idea that allows us to be really adaptable. I think one thing that we're looking at in the future is the idea of moving some of those functions to the edge, where we can do computation before even sending it to the cloud. I think that's a really great use case for only send data when you want, instead of always sending all the data for all the devices. Only send it when it starts to get sick. And these kind of things will really optimize the customer's experience and what information is required to be sent. So, there's a lot of exciting things coming up, but, we're happy to be part of it. And Cosmos team has been great partners for us. And I continue to look forward to what else we come down.
Okay. Thank you. Thank you. So let's hear now from Andrew from ASOS. How are you using Cosmos DB and change feed?
Thank you. Hi, everybody. My name's Andrew. I'm an architect at ASOS. So who are ASOS? If you haven't heard of us before, we're a fashion e-commerce retailer. It's our mission to be the #1 fashion destination for 20-somethings. We were founded in the year 2000. We've grown 30% year on year ever since. It's been a wonderful success story. And we're now sort of a $2 billion a year annual turnover, US dollars. We've got no physical stores. We engage with our customers through the website, through our native mobile apps, and through social media. The incredible growth we've had over the last sort of 18 years is significant to us, because we've had to find ourselves moving away from our on-prem architecture. We now deliver to over 200 countries. We've got people coming from all over the world visiting our website. So having a website based in London, SQL Server based in London, that's no longer an option. So 5 years ago, we went on a big re-platforming exercise. We decided to move everything to the cloud, and we were looking for a replacement for our sort of SQL Server, MongoDB story that we had. We came across Cosmos DB, and it looked absolutely good for us. It had strong SLAs, geo-replication, all these wonderful things. But when the change feed processor was announced during that time, it was a bit of a game changer for us, and I'll explain why. So we have a microservices architecture within ASOS. We're using the change feed in a variety of scenarios, such as pricing and payments. But the one I'm going to talk about, the team I used to work in, is the order management team. So right now we're building out a returns solution where you can go to the portal and book your return. So the idea being you You order 5 items of clothes, you try them at home, you send 3 back. So traditionally you had to send the parcel back in the post, and you wouldn't get a refund until it had been received by the warehouse. We're giving you a portal now where you can book that return online, and as soon as the carrier picks up the parcel, you get a refund. It's a microservices-based architecture, so we've got a load of building blocks, very small pieces of code, forming the workflow, and it's very event-driven. So from the moment you book the return, it goes into a validation process, and then once the return's been accepted, then we book a collection with a courier, so they'll come to your house and pick it up, and then we generate a returns label. In the past, we used Azure Service Bus as our transport to pass these messages around, but now we use the Cosmos DB change feed, and we choreograph these processes together to build out the workflow. If we look at a typical handler, this is one of our services here. So when the collection's booked, it's going to go into a document generation service and then emit a document created event. So here's our handler. The first thing we do is we load in the previous events into our aggregate. So I should say at this point we're using the event sourcing pattern. We have an immutable log of all of the actions that have ever occurred for that return, and it's great. We have a good strong audit log, and if we need to, we can go back and replay those events into a new system, a new database. We can recreate errors. Next thing we do after we've loaded up our aggregate with its state is we generate the return document. So here we might call out to a third-party web API, we'll download a PDF, save it to blob storage, and then we emit our document created event. And what we do there is we just append a new document into Cosmos DB. The Cosmos DB change feed then allows another service to pick up that change. As you can see there, it's 5 lines of code, really simple to test. It's got an input, an action, and an output, very easy to mock and test. And being so small and simple, it makes it ideal for Azure functions. When we plug it all together, this is a diagram of more of the process in its action. You can see here that all of these services are now connected by Cosmos DB, and the events are flowing through the system and ultimately ending up with the refund to the customer. As I said, what's good about the change feed processor is that it works on the sequence number, and you can rewind if you choose. So we had an incident once where a third-party system lost a load of data, and we were on the phone to them saying, can you back up, can you back up? And they were struggling to do the database backup. In the end, we said, do you know what? We'll just rewind the checkpoint on the collection, and we just re-pushed through all the events again, and it was up and running in an hour. So we were faster than their restoration process. So let's talk about hosting options. When we started out a few years ago, we had cloud services available to us, and cloud services, and cloud services. So we didn't have much choice. Cloud services, very low density, slow to provision, and expensive. So if you imagine one of those services, we probably wanted 3 of them to give us some resiliency. Then we wanted it in 2 regions. Before you know it, we've got 6 worker roles. You know, just for one of those services, multiplied by another 10 or 15 services, we're deploying a load of stuff. So now the future's a lot more dense. We've got Service Fabric, Kubernetes, and of course Azure Functions available to us. Pros and cons for each of them. We're now writing all of our handlers in .NET Core, so the news to hear about the Azure Functions runtime working in .NET Core is great news for us. That gives us ultimate choices between how do we want to host this. Some other thoughts from me, because we've had a bit of experience in doing this, some things I wanted to call out. So dead lettering is one of them. So if you're using an Azure function as your trigger, when we were using ASB, we had the dead letter queue. That acts as a good circuit breaker. So if you've written some code and it's listening to messages coming in, and maybe you've deployed a new version of the code, or your message has changed something, and there's an error, at least with the ASB, it'll retry and eventually dead letter. What you don't want to happen with the change feed is for you to be stuck in an infinite loop trying to process that change. So you might need to consider writing, some code to catch that exception and perhaps park the change and deal with it later. We have discussed this with our partners at Microsoft, and we're hoping soon that this might find its way into the change feed library. Security is another thing to consider. For us, we've got some data that has PII information in it, personally identifiable information. And with GDPR, we need to think very strongly about our security. So some other things that have happened recently, now Cosmos DB works with VNets, so we can apply a network security group rule around it, therefore making sure our handlers are only communicating within VNets and we're not going out via the public IP. Now, if you're using the Azure Functions consumption plan, you don't have that option available to you, so that's something to consider. That might affect your choice of how you use Azure Functions. At that point, you may want to start thinking about the app service plan. The other thing I wanted to talk about was Azure Functions runtime. So that's another option available to us. I know it's only in beta at the moment, but you could have your Azure Function runtime hosted in a container. And then you have the best of both worlds. You have the nice deployment model, the nice development model of Azure Functions, but you can choose to host it on your container orchestrator of choice. But you're obviously then losing the true serverless part of it because you're now needing to manage the scalability. My final thought is Cosmos DB and the change feed are cool. We love it. We're using it lots and lots now. We really like it. Thank you.
Thank you, Andrew. Thank you. So before we get into the question and answer, give me just a minute. I want to show you the thing I was talking about binding. So this was the code I wrote where I am instantiating this whole queue thing. But if I want to turn it into binding, all this 4-line goes away, and I just write one attribute here, return traffic queue connection, and that's about it. And host.json will have the information about connection. It's saying the binding out. So in my function, I'm just returning a message, and that's it. So just I wanted to show you quickly how simple everything becomes. Now let's have a question and answer. Chris is with us. He's one of the founding members of Azure Functions. So we heard so much about Azure Functions. Now he's kind enough to come in this session to answer all of our questions. And one more interesting thing is he joined Cosmos DB team too. So come on, Chris. Hey, Andrew, you guys.
Hey, everyone. How's it going? So yeah, if there's any questions on Cosmos DB, Azure Functions, we can field them here. We actually used the change feed and kind of the event sourcing pattern. I love hearing that for that red T-shirt demo that you saw during the keynote. That's what I spent my last 3 weeks kind of assembling with a couple of other folks, trying to get that happening lightning fast, so tuning lots of knobs, trying to make sure that the latency was about P99 at 2 seconds was my goal, and for the most part, the latency was like 700 milliseconds, which was pretty good.
And if you don't want to ask questions now, we will be down there in the booth till evening. Come there also or ask any questions. There.
Hi, my name is Peter. I have a question about disaster recovery. What's the story behind that? So when an Azure function somehow there's a big disaster and you start to recover from that, how do you make sure that you are handling all the changes that will pass through?
Yeah, it's a good question. So if you're using the change feed processor, you're using the change feed trigger for Azure Functions. Effectively what's happening is it's underneath the covers using the change feed processor host, the same library that you can use within your own code directly. That's saving the checkpoints inside of a collection inside of Cosmos DB. So if for some reason the function just isn't responding at all, it's dead, and you're like, what's going on? The checkpoint's still saved. So effectively what you can do is you can actually point a brand new function app. Let's assume that that one's just completely toast for some reason. You can take the exact same code, exact same settings, and point it at the same collection, and it will resume from the previous point. And so that's how you make sure that you never lose that state. And you can also go through there and then change that checkpoint if you wanted to go like back in time and replay events. This is good because you can even go ahead and point a function app in a different region. We'll say the whole region's down at that Cosmos DB collection and then fail over to another region, and it'll resume reading from that region.
Okay, thank you.
Mm-hmm.
Can I get a change delta for a record using the change feed and Azure function?
So today, what you get in the change feed is the final form of the document. So whenever you ask for the change feed, and if the changes happen before that, that will be lost, but you'll get the final form. But if you are listening to the change feed continuously, all the changes will keep coming to you.
My suggestion for if you're trying to go for a pattern where you need to know the delta, you can really look at doing the event sourcing type of pattern where effectively what you're storing in the database, each record, you're just appending changes that you want to have happen. And then effectively your document that's being modified is the changes. And then your materialized view is effectively where you actually reflect those changes itself. So the event sourcing pattern can work really well for doing that kind of thing with Cosmos DB and change feed trigger.
Hi, myself Ashish. We talked about the event source, so just wanted to know, the event source, could it be outside Azure as well, on-premise applications, could that act as event source as well?
Right.
Sorry. As you are asking, can you hear the change feed from outside of the cloud?
Yeah, it could be a change feed. It could be a change feed, maybe arrival of some records on, changing of some records on Cosmos DB, as you said, or it could be arrival of a message on a bus.
Yes.
But could it be outside Azure? That source, can it be outside Azure? Can it be on-premise application on on-premise MQ or on-premise database, which can act as a source for my event change that can trigger a function inside Azure?
So two things. One is Cosmos DB is a PaaS service, so it's only on the cloud.
Yes.
But if you have other services which want to trigger the functions, there are options.
What I recommend looking into there is you have the more classical case of using something like Service Bus Relay as an integration between your on-prem services and your cloud-based services. You can use Relay to effectively pump messages into a service bus queue or a topic, and then have functions running in the cloud using those. And on-prem, you're using Relay to basically deliver those messages in a secure manner. One of the more kind of new ways of doing this might be using something like Event Grid. Event Grid's great because you can basically publish custom events with schemas, et cetera, and then have functions and other things like logic caps listen on those events. So I'm kind of leaning towards Event Grid as one of the newer things lately to do this, but the classic pattern is to use something like Service Bus Relay, pumping messages to Service Bus queues, and then having things listen on those functions, logic caps, et cetera.
Thank you.
Yeah, so just a quick question about your demo code there. It looked like you had your function that was listening to the change log, and you were processing all the changes as they come in. Mm-hmm. Is there anything inherent in the function's runtime that'll parallelize that?
Oh, so when you are writing the function, mm-hmm. it is basically your C# code,
right? And
you can do there anything. You have a list of documents has come to you. For the simple demo purpose, I just said I'm going through the loop, but you can take it and parallelize or do anything.
Okay, but inherently in that function, there's only ever one copy of your function running.
What?
So functions is so one important thing to think about with the change feed processor. Mm-hmm. it is effectively a partitioned log stream, and so you basically have to be taking off the partition in mm-hmm. order in order for you to maintain what your checkpoint state is. So what will end up happening is the function app will scale out to the number of partitions that are underneath the covers for Cosmos DB. And functions automatically will scale you out and make sure that you're getting maximum scale for the number of partitions that you have. But each partition is processed in order. And that's where some of the things like dead letter handling is important, because if you block the processing because you have a bad message inside of there, your whole partition is slowed down. And so you want to basically take any bad things, dump them to a queue where you can handle it kind of elsewhere, and then keep processing the feed as fast as possible.
So yeah, basically you'd have an instance of your function per partition, and then if you wanted to further parallelize within that, you could shell off to another function.
Yeah, so you can use queues to further do batches of work from there.
Right.
Cool.
So I would like to add one more quick point. When you are using the processor SDK, and you can start 6 or 10 instances of an app which is listening to the same change feed, because the fact that you are using the processor SDK, it smartly divide the partition between the instances. It knows, okay, two apps have come to listen, so it will give 5 partition. You start another instance, and it will give 3 and 1 4. And you do have your own, you can write your own algorithm to divide the work. So that's also option is there. So in the processor SDK. And Azure function is beneath the scene, it uses SDK.
Hi, Oscar here. So quick question. Does the change feed accounts for request units. Let's say I have n requests coming into my database, and I will have n change feed events.
Right.
Will that account for my request units?
For RU, yes, because the data is moving out of the database.
So basically, I will double my RUs by just using change feed.
Yes.
It's not necessarily doubling your RUs because keep in mind that reads are cheaper than writes. But there is going to be, you can look on the actual header for what your RUs are from the change feed library. If you're using it directly from the Azure Cosmos DB SDK, you can very quickly see about how much RUs it takes. It's not the same as writes, so it's much cheaper than that.
True, because write we are writing 4 or 5 copies, right? 4 copies, and read will be 1. So yes, and then when you are using the processor library, it creates another collection called lease collection, and that will be extra cost on you because we keep all the bookkeeping, all the on the continuation token, etc., on the lease. So there's one more collection is created by the change feed. Yeah.
How does it work with a function app if you need to install a NuGet package?
That's a really good question. So there's 2 options for doing C# functions today. Same thing for F# more or less. You've got the CSX model where you effectively use a packages.json or something along those lines. And then we go ahead and do the NuGet restore at basically startup time for the function app. I don't really recommend that pattern as much today for people who are trying to do something which is kind of more robust and long term. It's a great way of getting started. But I think that the best way of doing this long term is to actually just use the Visual Studio project for Azure Functions. And what that effectively is just a class library with annotations in it that we then load, and we use those annotations to figure out, OK, this is the function we're going to call for this particular event. That's what the annotations you saw in Rafat's code was. There you manage NuGets like you do for any class library. You can effectively just use the NuGet package manager, choose whichever packages are compatible with your functions, and it should, quote, just work.
Will it work if the NuGet package is on a private repository like Artifactory?
Yes, and it's just like it's a class library or another web app. You'll need to make sure that your Visual Studio or your CD pipeline has access to that private package. But the functions runtime doesn't need to know, if you're using the second model, about where that NuGet package came from. You're shipping the binaries when you deploy to it.
Okay.
Okay. Good.
Okay. Thank you, everybody. And we are, looking for people to come and help us build the next generation. So please try this. Go ahead.
Just wondering if the functions is the future for replacing completely microservices architecture implementation like in a Fabric or Kubernetes, or it's just going to complement that?
It's definitely a complementary story. Things like doing heavy stateful services, things where you want high control, that's going to be Service Fabric's domain. You definitely want to kind of think about the offerings that Microsoft has, old and new, as a spectrum of things where we're trying to basically give you options for high control scenarios and options for high productivity scenarios. So you can think of functions as always kind of being at the very far side of high productivity. We're going to try to take away as much control from you as we think we can get away with while you're still being productive and able to do interesting scenarios. Whereas on the other side of things with something like everything for just running your own VMs and your own stuff on top of your own VMs, moving up to Service Fabric and AKS. And you have things like AKS with ACI, where your instances themselves are managed, but you have control over the infrastructure. Then you kind of move into app service land, where it's still instance-based pricing, but there's a lot of stuff like the front end taken care of for you, et cetera. Sure. And then at the very far right, you've got functions. So you can think of it as a spectrum of offering, depending on what your solution needs. If you feel like you have something which is going to require more control, you can use something on the left, as I call it, the service fabrics of the world. And then if you're trying to just be fast and quickly get something out, functions is a great choice. My biased opinion is to always start with functions because it's fast and you'll fail fast. And then you can go ahead and move down the stack to things that give you more control. Whereas if you start with something which gives you high control out of the box, it'll be hard to give up some of that control as you move up towards functions. So that's my general advice.
Thank you.
Okay. Thank you. Thank you, everybody.